Ascorium supplies 2D and 3D composites using its in-house produced polyurethane in tailored constructions, which include lightweight in-mold finished parts for automotive, marine, and recreational vehicles.
Well, Ascorium has a long history. It dates back from 1778 in Belgium, Europe. So at that time we started with gunpowder. Today, basically everything we do has something to do with polyurethane. So we are, at one hand, we're a chemical manufacturer, so we blend our own systems, and then we're also a part converter, so we use our own systems to turn them into parts. A big part of it today is composite parts, so we are pretty big in the interiors for the automotive, where we make a UV stable polyurethane skin. So the core is polyurethane. Inside the composite, there are two glass fiber layers that are separated by a spacer.
Ascorium has also developed a chemolysis recycling process that uses enzymes to recover 95% of the polyol from shredded PU composites at end of life. The polyol is then reused in new parts.
So we have a lot of options. So for example, here what was done here was we took organo sheet and bonded it with a covalent bond to our core material, which creates actually a lightweight panel, but with an extreme strength. So this is definitely a replacement for steel, but then lightweight. So this has been tested to make 45-foot bottoms of sea containers, out of one place, just held in place by a U-frame, and with a load of about 120,000 pounds, and then the 100,000 lifts that the industry requires. So what we're looking at here is the convertible for the BMW 8. So as you can see on the picture below, it replaces a part of the steel of the trunk. A couple different technologies in here. First of all, we have a very aesthetic looking and warm feeling A-skin, also made of polyurethane, but an aliphatic polyurethane. The advantage of using an aliphatic polyurethane is that the part becomes UV stable. So it will hold the color, but maybe even more important than the color, it will also hold the properties. So this is done in an upside down tool that has the surface structure, and then since our material is a liquid that we spray, it reproduces exactly that structure that was given to the tool. Once that is done, and now I'm going to flip it around so you can see it better. So once that is done, because this is the way we're going to form the part. So first the skin is being sprayed, then we're going to take that composite layer of the two fibers with the spacer, we're going to lay that on top of the tool. These inserts will be placed in the top of the tool, and then we're going to again spray an aromatic-based polyurethane over it. Because the material is liquid, it will sip through all the different layers, bond automatically or naturally to the skin. Then we're going to close the tool, let it cure for a little bit, release the inserts, and when the tool opens, you have actually a finished part that's not only decorative, but also very structural. Of course, polyurethane had a little bit the name of being not recyclable, so we wanted to fix that. So we developed a process which is called chemolysis, where we actually can take this part, regardless of the glass fiber, regardless of the inserts, we're going to shred it in smaller pieces. It's going to go in this process, which is basically a slightly heat up tank, where we're going to add enzymes to it. This process will take place and extract all the polyol out of the solid component. We can put about 100 in. Let's say we put 100 in, we get 95 out, but then in the shape of polyol by itself. And that polyol then we can use to make exactly the same part again.
For more of the latest composites industry news and innovations, visit CompositesWorld.com.